Our next topic in this chapter is the compounding frequency and the effective annual interest rate. So, why compounding frequency is important? Use a very straightforward example. In our daily life, almost every one of us uses credit card. But do you know how much interest rate that your credit card charges you in case you're not paying off your balance? So I guess here everybody understands how credit card works, right? You purchase with credit cards, and then at the end of the month, you pay off the credit card company by paying off the balance. But in case you do not pay off the balance, the credit card will charge you interest on the remaining balance. So do you know how much the credit card charges you in case you're not paying off the balance? So in the credit card contract, that interest rate is called APR, stands for annual percentage rate. Okay, and this is also what we call a nominal annual interest rate. A nominal interest rate means a quoted or stated rate. So it's the interest rate that's on paper. However, the credit card company do not actually charge this nominal annual interest rate on a yearly basis. Actually, because the compounding frequency is most likely different than yearly, so the actual annual interest rate that the credit card charges you is most likely slightly higher than what the nominal annual interest rate says. So that actual annual interest rate is what we call the effective annual interest rate. So the nominal annual interest rate is not the actual interest rate the credit card company charges. It is actually the effective annual interest rate. Now, how do we go from nominal annual interest rate to effective annual interest rate? We have to convert the nominal interest rate to effective interest rate based on the compounding frequency of the interest rate. Now, to convert the nominal annual interest rate to the effective annual interest rate, first of all, we have to convert the nominal annual interest rate to the periodic rate. So how do we convert that to the periodic rate? The periodic rate is the nominal annual interest rate divided by the compounding frequency of the interest per year. So for example, if the nominal annual interest rate is 12%, and if the compounding frequency is quarterly, that means 4 times a year, then the periodic rate is 12% divided by 4, that's going to give you 3% per quarter. So based on the compounding frequency, the actual annual interest rate or the effective annual interest rate can be very different. So let's look at the example on a slide. Suppose we're going to deposit $100 today, and the interest rate is a nominal yearly rate, 12%. However, the compounding frequency varies. So what will be the future value? Well, if the compounding frequency is yearly, then the future value would just be the present value, 100 times 1 plus the yearly rate, 12%. So that's going to give us $112 as the future value. Now, if the compounding frequency is a semi-annually, so the future value will be the present value, 100 times, in the parentheses, 1 plus the periodic rate, which will be the nominal yearly rate, 12%, divided by the compounding frequency per year, which is 2, and that's going to give us 6%. So in the parentheses, 1 plus 6%, and then close the parentheses, raise that to the power of 2, because it's compounded on a semi-annual basis. This means that $100 initial deposit will be earning 6% every 6 months for 2 6-month periods. So the future value is 100 times 1 plus 6%, raise that to the power of 2, and then the future value will be $112.36. So if you compare the semi-annual compounding to the yearly compounding, you will find that the semi-annual compounding is slightly higher in terms of its future value. Now, what if it's quarterly compounding? If it's quarterly compounding, again, we have to calculate the periodic rate first. So 12% divided by 4, that's going to give us 3% per quarter. So the future value will be the present value 100 times 1 plus 3% per quarter. Close out the parentheses, raise that to the power of 4. That means it's compounded 4 times within a year. So the future value will be $112.55. And compared to our annual compounding and the semi-annual compounding, you will find the quarterly compounding is higher. And then monthly compounding, again, we have to calculate the periodic rate. So 12%, which is the nominal annual interest rate, divided by 12, which is the compounding frequency per year. And then you will have 1% a month. So the future value will be the present value 100 times 1 plus 1% per month, raise that to the power of 12, and then the future value will be $112.68. So this is the highest so far among all the different compounding frequency. And then can we be even higher in terms of the future value? Yes, if you look at daily compounding, it will be the periodic rate calculated as the 12% nominal yearly rate divided by 365. And then we will have the daily rate. And then 1 plus the daily rate, raise that to the power of 365, and then multiplied by the present value 100. We will have our future value. In this case, it will be $112.74. So if we look at all the calculated results, the daily compounding offers the highest future value. What does that mean? Well, the more frequent you compound your interest rate, then the higher the future value you will have. And in this sense, if you are the credit card company, which compounding frequency would you like? If you can compound it on a daily basis, of course, that's what you want to do. You wouldn't choose to compound it on a yearly basis. And most likely, your credit card company will charge you interest rate, well, with a nominal or stated annual interest rate, but the compounding frequency is not going to be annual. It will be daily. And for the other types of loans, like mortgage loans, auto loans, well, you will not have daily compounding, but most likely you will have monthly compounding. And some people might ask this question, can a compounding frequency be more frequent than daily compounding? Well, yes, we can. It can be based on hourly or minute, or it can be a continuous compounding. So every second, every millisecond, the interest rate is being compounded. So that's beyond the scope of this class. But continuous compounding, it will be the most frequent compounding out there. Now, we have a generalized formula to convert nominal annual interest rate to effective annual interest rate. So first of all, let's calculate the periodic rate. So the nominal annual interest rate divided by the compounding frequency, that's going to give us the periodic rate, added to 1, and then raise to the power of p, which is the compounding frequency per year. And then the result, subtract 1, and that will give us the effective annual interest rate. So if we're using the semi-annual compounding as an example, then the periodic rate is 12% nominal annual interest rate divided by the compounding frequency, which is 2. So the periodic rate is 6% every 6 months, added to 1, and then raise that to the power of 2, and then subtract 1, we will have the effective annual interest rate of this 12% nominal annual interest rate, but compounding on the semi-annual basis. And this effective annual interest rate will be 12.36%. So to put it in plain English, if you are charging an interest rate of 12% nominal annual interest rate, but compounded on semi-annual basis, it's like you are charging a 12.36% annual interest rate on a yearly basis. So these two are equivalent. Now, how do we use the financial calculator or the Microsoft Excel spreadsheet to calculate the effective annual interest rate? Well, let's look at the TIBA2 Plus financial calculator. So look for the yellow button second, and then press number 2, which is same as interest conversion. So I convert. And then on the screen, it's asking you what the nominal annual interest rate is. And using the same example, we have the nominal yearly rate as 12%. So under 12 in there. And in the TIBA2 Plus financial calculator, always ignore the percentage when you enter the interest rate. So under 12, and then press the Enter key to assign a value to the calculator, and then use the down arrow key to navigate. So press down arrow one time, and then you will see EFF. That stands for the effective annual interest rate, which is what we're looking for. And then we need to skip that and then use the downward button to go to the compounding frequency. So press the downward button second time, and you will see on the screen, it's asking you what the compounding frequency per year is. So C/Y, that stands for compounding frequency per year. And in this case, it will be semi-annual compounding, right? So we enter the value of 2. And then don't forget to press the Enter key. Now you can press the upward arrow to go back to EFF. And once you're back on EFF, press the Compute key, CPT, to get the effective annual interest rate. And in this case, you should get the same number, 12.36%. So that will be the effective annual interest rate of the nominal annual interest rate 12%, but being compounded on semi-annual basis. In the Excel spreadsheet, highlight any cell, and then in the cell, type in the equal sign, and then type in EFF ECT, which is the built-in function of Excel to calculate effective annual interest rate. And then in the parentheses, you need to assign a value to the parameters. The first value is the nominal interest rate, and the Excel, which will take a percentage, you will have to type in 0.12, that's 12%. Use comma to separate, and then type in 2 as the compounding frequency, and then close out the parentheses, press Enter key. You should get the same answer, the effective annual interest rate of the nominal annual interest rate 12%, but the compounded on semi-annual basis, and that should give you 12.36% as well.